In this video lecture, I would like to introduce how to obtain the quantile for a given data, and we look at how to calculate the quantile through the statistical program R. First, we look at the definition of a quantile, and then I will introduce how to find the quantile using the simple example, and we use a quantile function in the R program to examine the result. You know, the quantile is the cut point dividing the range of distribution into continuous interval with equal probabilities. For example, for quantile, that is a quartile, means the 3 point, which is the sorted data into 4 equal parts, like this. Okay. However, it is not easy to find a point that divide the data equally. So we use the R program for calculating the quantiles, and the program provides a quantile function, okay, to calculate this point. And this function have a total of 9 types of options as a quantile calculation algorithm. As you can see, there are 9 types of quantile calculation algorithm. Okay, this algorithm type is divided into discontinuous and continuous. Okay, the type 1, 2, 3 are discontinuous type, and the type from 4 to 9 is the continuous type. Okay, I will not introduce them all in this video lecture. However, the most often used type, that is type 1 and type 4 and type 7, will be covered with a simple example in this video lecture. In particular, the type 7 is the default option of the quantile function. Okay. Type 1 is a representative type of the discontinuous method. Okay. Let's look at an example using type 1. You have data as follows: 4, 10, 2, 9, 3. And first, sort the data like this: 2, 3, 4, 9, 10. And we'll plot the quantile function like this. Okay. After sorting the data, set the smallest value 0. Okay. 0, and the largest value to 1. Okay. And if probabilities are given, the corresponding quantile value is obtained. For example, when a probability is 0.5, while then the quantile point like this. Okay, and we can write 0.5, and you know, this point is their median. Okay, and when the probability is 0.25, like this, we can write this, and it means the Q1 in the quartile. Okay, and we express this relationship in a plot. Okay, so put the probability on x-axis, probability, and the corresponding quantile function on y-axis. Okay, quantile function. If we know this function, quantile function, we can get any quantile value given a probability. In this example, the data is the 2, 3, 4, 9, 10, and the number of data is 5. Okay, 5, and we know that the minimum is 2, and the minimum is 2, and maximum is 10. Okay, and since number of data is 5, the location in this data is 1 divided 5, 2 divided 5, 3 divided 5, 4 divided 5. This is 5 divided 5. Okay, and these pairs, ordered pairs are plotted as follows. The minimum is 2, maximum 2, and when the probability 1 divided 5 is also 2. Okay, and 2 divided 5, then the corresponding the quantile is the 3. 3. Okay, and the probability is 3 divided 5, and the corresponding quantile value is 4. Okay, and 4 divided 5 is 9. Okay, and the maximum value is 1 equal 5 divided 5. Okay, and the 10. Like this. Okay, and in type 1, the function is expressed as follows. That is step function. Okay, as you know, this point points are discontinuous. Okay, so type 1 is called the inverse of empirical distribution function. And let's calculate the for quantile, that is quartile, using type 1. Okay, the Q1 means the Q 0.25, and then in this the quantile function like this 0.25. Okay, this value is 3. Okay, and Q2 is the quantile 0.25, and like this. This point is the quantile is 4. Okay, Q3 means the probability is 0.75, and then this quantile is 9. Okay, The out program provides the quantile function. X means the data, and probus option means the probability. So if you set the type 1, and then you can get the quantile of the data using the type 1. Okay, for example, you want to know the Q1, the first quantile, and using type 1. Then we can get this point using the quantile function like this. Quantile and x equal data, and probus equal 0.25, and type equal 1. Okay. Now I will show you how to implement the quantiles by the type with an out program. Okay, so first enter data equals 4, 10, 2, 9, 3. Then we make the data value, and we use the quantile function. Quantile, okay, and option. There are 3 options. That is x equal, probs equal, type equal. Okay, and let's find the quartile using type 1. So type equal 1, and x means the data. Okay, so data, and prob is 0.25. That is, this value is Q1. Okay, Q1. Okay, so we can get the 3, and Control C, Control V, and the median equal prob 0.5. That is the 4, and when the probs the 0.75, we can get the Q3 9. Okay, 3, 4, 9. Okay, or to obtain the quartile, you can use this function x equal data and probus 0.25, 0.5, 0.75. Okay, and type equal 1. Okay, so you can get there. Also, you can also this quantile using the type 1. Let's take a look at type 4. Type 4 is a linear interpolation. This is one of the continuous type. We have 5 data as follow, and this 30 data is like this. Okay, minimum value is 2, and the maximum value is 10. Okay, and we know that the positions, this data, 2 is 1 divided 5, 3 is 2 divided 5, 4 is 3 divided 5, 9 is 4 divided 5, 10 is 5 divided 5 equal 1. Okay, and these pairs are displayed in the plot as follow. Okay, 0, 1 is 2, and 1 divided 5 also 2, and 2 divided 5 is 3, 3 divided 5 is 4, 4 divided 5 is value is 9. Okay, and the maximum value is 10. Okay, and in type 4, these points are linearly connected to each other like this. Okay, like this. That is, the quantile function is use the linear interpolation. Okay, let's find the quantile in this data using type 4. Okay, you know, the Q1 means when the probability equals 0.25, then the corresponding value. So the position when the probability equals 0 to 5 like this, and the corresponding value like this. Okay, so this point is Q1, and Q2 equal Q 0.5, that is this point. Like this, Q2, and Q3 equal Q 0.75. Okay, this point is 0.75, and the corresponding quantile value like this. Okay, as you know, if you get the this quartile point, and you can calculate the linear function in each interval. Okay, so to be obtained the Q1, you calculated this linear function. Okay, this, and you know this 2 point, so you can calculate this linear function. P equal a small a plus small p multiply the probability. Okay, so this means the interception. This means is a slope. Okay, so a equal 1, b equal 5. Okay, so Q1 equal 1 plus 5 multiply 0.25. Okay, so the Q1 is 2.25. Okay. As this like, you can calculate this linear function. QP equals small a small p multiply probe, then a equal 1, p equal 5. Okay, so the Q2 is 1 plus 5 multiply 0.5, that is 3.5. This linear function is equal a plus b multiply probe, then a equal 25, b equal a equal minus 11, p equal, that is slope is 25. So quantile 3 is minus 11 plus 25 multiply 0.75. So Q3 equal 7.75. Therefore, we calculate the quantile using type 4, that is Q1 is 2.25. Q2, that is median, is 3.5. Q3 is 7.75. Let's look at second continuous type, type 7. Okay. Type 7 is default option of a quantile function in the out program. Okay, and we use this point. Okay, then and data 2, 3, 4, 9, 10, and the corresponding probability equal 1 divided 5, and 2 divided 5, 3 divided 5, 4 divided 5, 5 divided equal 1. Okay, and we use these pairs to draw the quantile function, right? And in type 7, these order pairs are transformed like this. Probe type 7. This is 0. This is 2 minus 1, 5 minus 1. That is 1 divided 4. Okay. This is 3 minus 1, 5 minus 1. That is 2 divided 4. This is 4 minus 1, 5 minus 1. 3 divided 4. This means 5 minus 1, 5 minus 1. That is 4 divided 4. That is equal 1. And draw it like this. 0, that is minimum, equal 2. And 1 divided 4 equal 3. And 2 divided 4, that is the quantile is 4. 3 divided 4, the corresponding quantile value is 9. And 4 divided 4, that the maximum value is 10. Okay, so we have a point, 5 point. Okay, and we connect this line. Okay, so in order to obtain the quantile value, so we can find the function of its interval, right? Yeah. So this interval is 2 plus 4 probe, and this interval, that is the linear function of this interval, is 2 plus 4 multiply probe, and this interval is minus 6 plus 20 multiply probe. This interval 6 plus 4 multiply probe. Okay, so using the type 7, the quantile is Q1 is Q0 0.25, is like this. So 2 plus 4 multiply 0.25. That is 3. And the Q2 is Q 0.5. And we insert this function, that is 2 plus multiply 5 equal 4. Okay, and the Q3 is Q 0.75 equal to we use this function minus 6 plus 0.75 equal 9. Okay, so in order to obtain a quartile using type 4, okay, type 4, you only change the type option. It's very easy. That is Quantile x equal data, troubles equal 0.25, 0.5, 0.75, and type equal 4. So you can get the quartiles using the type 4, and it's the same value in the lecture note. Okay, and the type 7 is like this, 3, 4, 9. Okay, let's look at another example. This data was covered in last week video lecture, how to find an outlier using IQL, and first sort the data like this. Okay, and the minimum is 3 and maximum is 300, and the number of data is 11. So this value is when the probability equal 1 divided 11. Okay, and this value is when the probability is 2 divided 11. Okay. Okay. So minimum equal 3 and the maximum equals 300, and okay, and we connect a line like this. Okay, So let's find the quartile using type 1. Q1 is Q 0.25 is this point is 0.25, and then quantile value is 8. Okay, the Q2 is Q 0.5 equal, and the corresponding value is 25. Q3 equal Q 0.75 equal this is 36. Okay. In type 4, that is linear interpolation. Then the quantile function is like this. That is, we use linearly connection like this. That is, we use the linear interpolation method. Okay. So the quartile in type 4, Q1 is Q 0.25. That is 0.25 is this point, and we can calculate this linear function in the interval, that is 33 multiply probe plus the interception is -1. Okay, so this is -1 plus 33 multiply 0.25 is 7.25. Okay, Q2 means the Q 0.5. 0.5 is this point. Okay, so this linear function is 66 multiply probe plus the intercept is -11. Okay, so the median, that is Q2, is -11 plus 66 multiply 0.5. So it is 22. Q3 is Q 0.75. That is this point. This linear function is 44 multiply probe. The interceptor is 0. Okay, so the Q3 is 44 multiply 0.75 equal 33. In type 7, that is the default option in the out program. We the probability of the data value is like this, and in type 7 we move the probability position like this. The first, the minimum is 0, that is second probability is 2 minus 1 divided 11 minus 1, that is 1 divided 10. Okay, like this. 11 minus 1, that is 2 divided 10. Okay, 3 divided 10, 4 divided 10, 5 divided 10, 10. So we draw the plot like this. Okay, first we put the this point and the connect linear. Okay. The quantile value using the type 7 is Q1 equal and their 0.25 position is, and this quantile Q1 value. So we calculate this linear function minus 4 plus 60 multiply flow. So the Q1 is minus 4 plus 60 multiply 0.25 equal 11. Okay. And the Q2 is Q 0.5 is Q2 position, you know, this. So this value is 25. Okay. 25. Q3 is the when the probability is 0.75. Okay, so this linear function is 4 plus 40 multiply pro. So Q3 Q5 equal 4 plus 40 multiply 0.75 is 4. Okay. Today we look at quantile calculation. Okay. When we have n data like this, x1, x2, xn, then we sort the data like this, small n, small 2, like this. Okay. Order data. We can grab the quantile function as follow. Put the x-axis with the probability, and the corresponding y is the quantile function. Okay, and this point is minimum, and the probability is 1 divided n. This point is when the probability is 2 divided n. That is when the probability is n divided n equal 1. So we draw the plot like this. 0 minimum is small x1, and 1 divided small n x2. No. Okay. 2. Okay. 2 divided n the x2. Okay. 3 divided n is x3. And divided n equal 1. That's the maximum is x. Maximum value. So in Taiwan, the quantile function is like this. Okay. This is a discontinuous type, and in type 4 is the quantile function can be used the interpolation method, linear interpolation method, and type 7, this is a default option in the quantile function, is we move this point like this point, and we connect linearly. Okay,